Actually, I'm a colleague at Mittuniversitetet with Hans Erik. Actually, at this university, we have two extremes of research. One extreme is obviously on the Hans Erik side, electronic design, essentially cutting edge part of it. I'm on the fiber-based packaging, essentially the paper. So we are actually, I'm working on actually basically taking edge part of the design. So that's what we're going to do. So anyway, the title of my talk is rather kind of modest, and I have to admit that it's very much not upbeat. But eventually, what I'm going to talk about is actually this. It's new product development in North America and Japan. Incidentally, I'm a professor at Miss University, but I'm a Japanese Canadian residing in Sweden. So that's the whole nationality. So since my background is mainly North America and also Japan, both in the research institute and also industry, so I try to bring in a little bit slightly different kind of insight and also view about this same topic, which we're talking about today. So perhaps maybe I should start from this. And the question is, what's happening in North America? There's nothing fancy happening actually. But at the same time, there's a very substantial change going on in this area. And this is a picture I took just 1 week ago at my house in Canada, Montreal, Canada. And this is simply just sack paper, 2-ply. And they used for the paper yard waste. And this is a very striking picture, actually, from North American viewpoint. Because there's nothing exciting, but actually very exciting one. Simply because obviously this bag is used for yard waste, particularly in autumn, putting all leaves and all this other yard waste there. But what is important is that these bags used to be completely plastic bags just 2-3 years ago. And eventually in this area, this is the first time we see all these plastic paper bags. And eventually, these municipalities no longer accept any of the plastic bags in this area. Even from this area, for example, from my house, I normally produce 20 to 30 this type of bags. And my neighbors too. That's a huge amount of paper bags used here. And even in Ontario, even northern US, they use essentially similar things. They used to use all plastic bags, but they're all completely replaced with paper bags. So certainly you can easily see that so-called strong tailwind for fiber-based packaging, so-called green trend. The Korea is not just talking and talking, but it's actually a reality now in North America. And of course, plastic also fights back. And this is a food bag for my dog, actually. I normally use it. And my wife is quite conscious about all this biodegradability and all this stuff. And she always buys this stuff, And although my dog doesn't care too much about this. And this biodegradability is obviously because the big things for plastic industry. So they put anything with biodegradable, so on, with green colors. That's what's happening. But we have to be very careful that what they call biodegradability in North America is not compostability. Do you know the difference in the semantics? We're really working very hard. Essentially, simply saying compostability means that when you put it in the soil, it goes back to the soil. Biodegradability doesn't. Okay, that's a trick. But anyway, as you can see that these two examples really represent what's happening in packaging areas and also what the direction of the development and so on and so on. And also issue as well. First of all, it's very obvious. Sustainability drive is now here. It's not a talking. It used to be. Secondly, competition with plastic is tough, extremely tough. Even the legislation is there. Through the paper packaging is really, having difficult time to fight. And as I said, semantics war is intense, biodegradability versus compostability, and also many plastic industry use LCA, basically life cycle analysis. This has been used almost completely politically to basically get some advantage in terms of logic to support the home material. So this is what's happening now. And of course, the number one challenge for the fiber-based packaging is cost versus performance. Essentially, cost. For example, when you take a look at this yard waste pack, compare these two. Eventually, I think this package contains about 30 bags. For plastics, about $16. For paper, it's $27. And obviously, it's very expensive. So when you have no constraint, obviously, people take plastic bags. But since because of the whole municipality regulation, then paper bag is still, floating around. And of course, performance challenge vary with application. That's obvious. But what is important is that because these three factors: cost, performance, and application. And many people talk about how much cost. How about the cost? Cost. Yes, cost is extremely important if you define the application. If you don't define the application, there's no meaning for the cost. That's very important. And of course, performance as well. So essentially, this cost, performance, application, this formula is actually the battleground in North America and also Japan. So what's happening in the North America and Japan, essentially? And essentially nothing happening, or very much similar things happening as in Sweden too, particularly in the typical paper packaging area. There are a lot of development going on. But certainly these two markets are extremely mature, staggered in many ways. This means that competition is very intense. This means that there is a lot of stretching going on, such as fiber-based paper, how much you can stretch the paper concept. So we really have to change the paper concept too. Secondly, the packaging concept. Packaging is not only just a consumer packaging you can see in grocery, but actually something which protects something. If you apply this concept, then packaging basically arena actually expands a lot. So what I'd like to show you today is a few examples. Essentially, what is distinction between the balloons and also successful new product development. Balloons being something you just advertise it, and news release and so on. This is the thing. But there's no cash flow. Okay? Successful new product development is something you have cash flow every month. At least you survive in the market 5 years. Then what we call successful new product development. So that's what I'm talking about. So that's really what distinguishes between these two. So packaging, actually this is the example of Japan. We are protecting something, but now just put it this way, protecting environment. One trivial example is that this put back. Obviously we have to protect our yard itself. At the same time, we can protect some air environment in the automobiles, and also some plant, business buildings, the home, and so on and so on. So this is a concept. So naturally, people go into that area as a kind of filters. The filters in the traditional sense is essentially the same, but there are a lot of development going on in this area. Basically, protecting the environment in many different aspects. So naturally, it requires multifunctionality. This means deodorizing, and also antibacterial, antivirus. This is very important these days in many of the environmental safety and work safety too. And also dust removal, and also removing some allergen in the home environment. So what people are doing is essentially, this is a kind of development. And this is one of the type of filters, so-called photocatalyst filters. Photocatalyst is something that it's essentially oxidize almost any of the material into decomposed into the carbon dioxide and water. So essentially they kill everything, including bacteria and other stuff too. And in this case, it's just a fiber-based material, such as shown here, typical fiber. And that's kind of filler-like stuff, you know. This filler is essentially composite. It's a composite of photocatalysis, in this case, titanium oxide of certain crystalline form, and also absorbent. Put them together, actually mix them together, and put it in the fiber network. It's a very simple idea. The only thing is that this photocatalysis is extremely strong oxidizer, meaning that it attacks fiber itself. So obviously it degrades the fiber. Therefore, it puts it into another kind of layers of kind of filler absorbent there. So that's how it's designed. And this actually expanding quite a lot in many aspects of the environment, including industries, home environments, and so on and so on, and also automobile. Particular automobile application is getting very, very serious. The second example is quite similar, but it's packaging controlled atmosphere. So when I talk about controlled atmosphere, most of the people say, that's the food packaging stuff. It's true, food packaging already controlling oxygen, the nitrogen, and all other different type of gases. But in this case, it's much simpler than that. Paper for heat moisture exchanges. Particularly in the northern country, even in the winter, it's very important to obviously preserve the heat within the house, but at the same time you have to exchange your air too. So obviously you lose heat as well as moisture, particularly in a dry environment that really gives a lot of problem. So how to do it? It's very simple. You have this box in the basement there. Eventually what you do is that this air is going out, another outside air is going in. And in this box, eventually it exchanges heat, retain the heat, and also retain the moisture through this very strange kind of corrugated box type structures. And since the paper is very good in terms of passing through the moisture, at the same time the heat conductivity is also good with some certain structures. Therefore, you can basically retain moisture so that you can prevent dry air. At the same time, you can also retain heat so you can save energy. The idea behind it that it's rather ironical. Many people are working on barriers for paper materials. So we keep introducing barrier property. In this case, we use paper as non-barriers. That's very important. So there's a twist here. And this is what everybody knows, that if you talk about any cellulosic material, paper, the glassine paper, and also even nanocellulose stuff, in terms of OTR, the oxygen transfer rate is much low. It's very good. In terms of water, it's very high. It's actually a problem, a disadvantage of cellulosic material. But in this case, it's advantage. So let's use it. And at the same time, if you trick a little bit in the sheet structure, then you can actually increase heat conductivity too. So from the point of moisture exchange and heat exchange, this is actually ideal materials. So this is how we put or look at the papers for the application. So that's the kind of concept. Obviously, this is a matured industry, so you really have to be innovative to expand or the extended paper concept. But in this case, there's no extension, it's actually twisting paper concept. What do you do is that essentially create yarn from paper. And the paper means that essentially you make paper first, very, very, very thin papers. And after that, you start replace shredding in the machine direction there. So you have one few millimeters kind of paper, thin paper there. Then you basically twisting and then making some kind of yarn there. So essentially, application is that obviously you have all apparel industries. You can attack interior type fabric market and bed clothing too. And of course, you can make perfectly clothing. Eventually, they're already marketing there. And what is important is that this application not only in this traditional textile area, but also industrial textile area. So artificial glass, those other type of material can be used. This means that paper textile packaging. Okay, so there's a lot of twisting. Now what is important here is that this type of material is very unique in the sense that it's washable, of course. Paper is washable. It doesn't dissolve. In this case, dry strength and wet strength is almost equal without any chemicals because of the structures. Therefore, actually, such soft textile packaging can be used. For that use, actually paper can be used without structures. So another thing, this is very simple, extremely simple idea. Stainless papers, it's literally sense it's stainless. What is it? Essentially, it's a stainless fiber. So we're not using wood fiber at all, but made of ultra thin stainless steel fibers. And basically, we actually use exactly the same paper making process, wet forming process. And it's actually, what is used for? It's actually electrical packaging, and particularly for electromagnetic shielding for PCs and most of the home electronics. This is actually used. It's very, very effective. At the same time, because of the controllability of pore structures, we can also use quite high-grade filters, like ink filters, actually. So this is how it's used. And what is important that this is only the application of the stainless steel fibers, but we can use, of course, a variety of fibers for different purposes. Okay. Then the last example is actually I put it frugal innovation barrier film. The reason why I said frugal innovation, there's no kind of fly-point kind of upbeat advertisement at all. Essentially, this was actually developed together with the kind of research, National Research Institute as well as one of the paper company called Tomoe Gawapia. It's just a film, very transparent film. And this is actually made of clay, no plastic. And this is actually the kind of bunch of clays, basically the layer in the thickness direction. With just about 30 micron thickness of the sheet, actually clay layers has almost 20,000 layers in the thickness direction. So what happened is that actually gas permeability is superb. It's extremely low gas permeability as compared to most of the barrier polymers. And what is more important is for higher temperature barriers, essentially, because polymers are very weak and higher temperature. So this is currently used for the barriers for the automotive, but actually they are actually developing for the food packaging as well. So just to summarize my talk, essentially, so what's really distinct between the balloon and also successful product development? The most important message I'd like to send is that looking at all these examples, essentially they always start from application, not from materials. Application is most important, but do you do rather than what material do you have? Secondly, the frugal innovation. Frugal means something modest. You don't have to start from the high tech. Let's look at just the basic there. Seems ordinary, but stretching your concept completely. So not me too ideas. And thirdly, many of the products are actually the multi-scale material design. That is essentially looking at very, very small, trick versus very large scale trick like corrugated board or honeycomb structure. So these things are happening in all different lengths. So this is very important design trick and also product development trick applied in this successful product development. Now actually this is one of the areas we are currently working at the university. Okay? That's all.
How far away are you the market with those examples you showed, or is it just in the lab?
Actually, the one I showed you, they're all in the market.
They're all in the market?
They already survived at least 5 years. So they are making cash. That's very important. So it's not a talk.
It's not a talk. It's real. It's out there. Thank you.
So it's done already. So if we start something obvious, we have to start from this further on.
Great. Questions, comments, ideas? I saw wheat gluten on one of your slides.
Yes.
Compared to other materials. How would you judge that one? We heard earlier that they believe very much in this kind of material.
Which one is
the gluten?
Gluten, yes,
yeah,
yes.
Yeah.
Of course, these materials are very obvious candidate for so-called bio material. But certainly we have to work on this. But in reality, looking at the application is very, very tough. The cost issue, performance issue too. So I don't think within 5 years or so we can find any application. It's too expensive. There's too much competition right now.